So this is a demonstration of automatic scaling back of gains for the cat tail sitter here with a new oscillation detector I've written. So here we are streaming numbers straight from the ArduPilot into MATLAB, and these top two graphs are calculated and are a duplicate of what ArduPilot does, and this bottom graph is a direct copy, and this is the scale factors that we're applying to the gains. So this is the before flight with the new stuff turned off. So let's just take off in Q hover and do a little forward flight. So you can see it's oscillating in pitch really quite badly almost straight away. And it settles out, but if I put in pitch inputs, you can see it is oscillating again. So this is without, so you can see the scale factors on this bottom graph are all staying at 1. And then this is, these top two graphs show what the code would be doing if it was switched on. So this relative oscillation amplitude being at 2 says it should reduce gains, and then this PID ratio, the D term is over 50%, so that says you should reduce D. So let's reset this vehicle, turn on the new stuff, and see how it gets on. So this is now with the oscillation detection switched on, so I'll switch into fly-by-wire as before. So we get the oscillations, but straight away you can see the scale factor for D has been dropped to half, which has completely stopped the oscillations that we were seeing. And you can see now it's reduced the feed forward a little bit, and you can see that slowly it's trying to get those values back up to 1, because you don't want to leave the scaled gains the whole time. It just is trying to stop oscillations. So this is not something that would be kicking in the whole time. You might have a bit of a bad launch and a bad wind estimate, and this would kick in for a bit, and then it would slowly decay back to 1, and you can see it's trying to do that. So if I fly with stick off for a bit, they're all back up to 1, so that's as we were flying before. But if I flick the stick and we get oscillations, you can see it's stomped on the D gain again there, which has much reduced our oscillations. And you can see if I keep flicking it so that the scale factor stays down, it's actually done quite a good job. But if we wait a little while for the scale factor to go up again, it will seem a little bit worse. So you can see it oscillates for a bit longer there because the scale factors have slowly increased. So this is just to sort of catch a bad tune. It isn't to replace. Like you wouldn't want it to be triggering the whole time. This is to trigger if something's gone wrong. But potentially we could use it for the basis of a special auto tune. So this is a demo for plane. So now I'm going to load up Copter and we'll see how it gets on there. So here I am with a Copter, and you can see this is a tricopter, and it's got a particularly bad yaw tune. So the oscillation detector has detected an oscillation. It's definitely P, it's really clear from this ratio graph, and it's cut the P gain to about half what it was. And I've actually set a 50% cutoff, because if some unexpected oscillations occur, you don't want to go half your gains. That might be too much. It might be an error with the detection, and we don't want to cull your gains down to 0. In this case, it isn't really unexpected, it's just a bad tune. So let's go and see what happens when we reduce the your P, because that's what it's telling us to do. It's already cut it to half. So if I cut it to half in the parameters here, so 4.7, let's go down to 2.2. So you can see that's completely stopped the oscillation, and in fact the oscillation detector has put the scale factor back up to 1. So if I yaw around now, it will be fine. So it looked like actually in this case the oscillation detector was only just limited before it was able to stop. Like if it had been able to go perhaps a little bit lower than 50%, it would have been able to completely stop it. So let's just see and put this back up to 4. So it's not detecting anything, but I bet if I yaw a little bit, it will start off. So that wasn't big enough. There we go. So that's a bad one. And straight away, it's bringing the amplitude down. And actually, I think it's struggling a little bit with yaw because it's quite a slow oscillation. So perhaps for yaw on Copter, we might want to consider using some different filter values. So it's actually stopped there, and the gain's gone back up. So this is sort of demonstration of why it's not very good to run all the to be running all the time, because as soon as the oscillation happens to stop, the gains get scaled back up to the previous values. And actually, if you have a bad tune, the previous values are not very good. So that seems much better now. So let's have a look at one of the other axes. So here we are with the tricopter. So you can see the tune is not great, and in fact the oscillation detector has cut the gains in half. But you see they're trying to get back up to 1, and you can see it sort of increases them a bit, hits oscillations, and then drops them down occasionally. So there, if I move a little bit, it actually does a little, it oscillates a little bit less when you're moving, because it's trying to do something, then it sort of damps it out. But there you can see you've got oscillations, and it quickly stamps on the gains down to half again. And now it's tried to put them back, and it's not succeeded. So maybe we might want to treat this a little bit differently on Copter, where perhaps it doesn't put them back so quickly as it does for plane, or it takes a little bit longer. I think that's going to be one of the challenges, is getting some parameters for the filters and the thresholds that work well on all the different configurations that ArduPilot has. So that's width. So I'm just going to land and turn off the scaling, and we'll just see how it flies without this oscillation detection running at all. So here we are back. So this is with the oscillation detection turned off. So these scale factors are all going to stay at 1. So you can see now the vehicle's just continually oscillating. So before, the scaling was getting rid of that for us a little bit. So maybe with the right parameters, it could make this much more flyable. Of course, it wouldn't be a good tune. I think the goal of this is just to flag up. You're having some oscillations. I've dealt with them for the moment, but you need to do something to fix them before you fly again. Especially for Copter. For plane, it could be that when the wind estimate comes good, it will be able to scale the gains back up to 1 and fly around no problem. So that's a little demo on Copter. So I think the next thing is to look at trying this on a real vehicle. Thank you.